Good afternoon, everyone. Thank you guys for being here today. We have Subbu Panzani, Senior Data Scientist in Applied AI and Modeling, and he'll be speaking to you today about SaaS Strategic Supply Chain Optimization. We'll try and save at least 5 minutes at the end for any questions that you guys have, but once he starts speaking, you guys can listen through your headphones. So thank you, guys.
Thank you. Thank you. Good afternoon, everyone. I'm excited to be here. Thank you for joining this session. My name is Subramanian Pazani. I go by Subbu. I'm a senior data scientist with the Applied AI and Modeling team at SAS. Today, I'll be discussing our SAS strategic supply chain optimization model and how you can use to disruption-proof your supply chains. Right? Our model supports optimizing your end-to-end supply chain to reduce cost, increase responsiveness by proactively identifying the best response to disruptions across your supply chain. Okay, let's start with the notional approach, an inventory-focused approach. Right? Companies usually start with inventory optimization, considering customers' demand forecasted at the retailer level. Right? With this forecasted demand and inventory plan as an input, then companies try to develop a production plan that can supply that inventory plan. But due to production capacity limitations and various other factors which causes this mismatch between the demand and actual operations, it can often be either not possible or very expensive to meet this inventory plan. Right? So adjustments such as modifying your production schedules or reallocating resources are made without considering the entire supply chain as a whole picture. Right? So this is time consuming and not optimal for the business. So our SaaS supply chain model examines the end-to-end supply chain, creating synchronized business plans across the enterprise for suppliers, for manufacturing plants, for inventory, for transportation and sales. These plans enhance collaborative decisions across key business teams, providing a more robust and holistic approach for your supply chain planning. Our model incorporates detailed cost and planning parameters. At the supplier stage, we consider raw material purchasing cost and we consider availability of raw materials at the suppliers. Our manufacturing plants considers production cost, line availability, production rate and other capabilities of the lines. Our distribution centers or any distribution facility, we'll talk about the features of the model, but we are going to call this distribution facilities as just one term, but you will be able to configure your supply chain dynamically based on your needs. Right? Our distribution facilities consider holding costs, storage costs. It also considers safety stock requirements to meet your desired service level along with safety stock penalty if the safety stock is not carried at your distribution facilities. Right? Transportation cost and travel times are considered throughout your supply chain across various stages, and the goal is to satisfy your customers' demand on time, right, with the minimum possible cost and maximum responsiveness. We understand the challenges you face in managing the supply chain, and our model is designed holistically to address those challenges efficiently. These are some unique key features specific to our strategic supply chain optimization model, starting with a dynamic model framework. Our dynamic model framework allows you to easily configure, model and analyze any type of network, any type of supply chain network structure and size. When we mean by size, it's a number of entities within a stage. When we mean by the structure, what we mean by the structure is number of stages within your supply chain itself. You could have no suppliers at all. If you want to just look at your manufacturing strategy, you could have multiple distribution stages. Say for example, you have a regional distribution center, you have a warehouse, you have a third party managed warehouse and a local distribution center for distributing your products. So all these different cases or structures of the supply chain can be easily modeled with the data. So we give a data model. With that data model, you will be able to modify your supply chain structure. Right? The Next key feature is perishability of goods. The model can handle both perishable and non-perishable products at a final product level, at a raw material level, and an intermediate material level. Right. The third key feature is alternative raw materials. This alternative raw material feature is a flexibility feature for sourcing teams. Right. They can use this feature to select any alternate raw materials which go into that product. Right. This will give a flexibility for the sourcing team to source efficiently. Multiple level BOM is our next key feature. We can consider multiple raw materials, multiple finished products, multiple intermediate materials in your bill of material structure. Connected flow line is another key feature of this model. If, for example, your manufacturing lines feed another manufacturing line within the same plant, those kind of connections can be considered here. For example, you are manufacturing a sub-assembly in a particular line, and that sub-assembly feeds another line in your system that can be efficiently modeled using the supply chain optimization model. Another key feature is your product upgrade or substitution. Our model handles seamlessly all these product substitutions at the retailer level when you need it, which time period you need it. It will handle this seamless integration or seamless substitution of product at your retailer stage. Along with it, a lot more features to efficiently model and optimize your supply chains. We are confident that we have all the features which will significantly enhance your supply chain management. Robust supply chains, right? Robust supply chains allow organization to respond dynamically and quickly to adapt to changes in the market. It could be market, it could be with the laborers, it could be with employees, it could be with any structure changes within the supply chain itself, right. Now, let us go to this potential scenarios that impact your supply chain and analyze these potential scenarios, right. Our model can help with addressing all these scenarios, or these are not the complete list of scenarios, these are some potential scenarios we are going to discuss, right. Starting with demand increase. Demand could increase due to promotions, market changes, a competitor leaving a market, right. How do you quickly respond to significant shifts in demand? For example, during COVID there was a significant rise in demand for PPEs and cleaning, this keeps automatically jumping, and labor strikes, line breakdown. How do you create alternative production plan when your bottleneck machine breaks down? Right, supplier disruptions, facility closure, and it could be a facility opening. You are trying to open a new production facility where you wanted to see how you can enable or how you can re-optimize your supply chain to address this new facility or include this new facility in your supply chain structure. Okay. So, coming to the modeling framework, because of all these things we need a flexible framework to have this model, right. Our model is a containerized independent model, has a Docker image which has SaaS runtime dependencies specific to the supply chain optimization model. Unlike other models where it is deployed within the entire VIA framework, this model is an independent model, containerized, and only has the dependencies needed to run this model. It also has a Python installation. We will explain why Python installation is needed, but the optimization code is deployed within this Docker image along with a model API. The model API is used to call the model and execute the model, right. So, the API with access endpoints is created to execute the optimization model. The optimization model itself expects a set of input files. These are the input files which comes from your business, right, like demand forecast, inventory levels, current inventory levels, your supplier's capacity, your supplier's qualification on which raw materials he can supply, DC and transportation capacities, storage capacities at your distribution facilities, manufacturing capability. When we say manufacturing capability, we are talking about what lines do you have, what can these lines produce, if there are any connection between these lines for producing these products, right. Bill of materials, of course, what is your structure of your product and how many material A is needed to produce your product B. All those details can be defined as inputs. This is processed here, or this is run through this optimization model, and we get a series of outputs. We will go through these outputs one by one, right. Some optimized decisions from the model, or these are the key optimized decisions from the optimization model. Starting from the purchasing side, we have the best supplier selection and optimal raw material purchasing plan from these suppliers for a given scenario. Again, we are going to look at some what if analysis scenarios, but for a given scenario, we get the best supplier selection and optimal raw material purchasing plan. Production decisions including optimized plant line manufacturing plan, which line in which plant needs to produce your product A or product B, and what is the quantity, which time period do you produce, etc., etc. Right. Distribution decisions including all the optimized flow of products from suppliers till it reaches your customers. Inventory decisions on how much inventory you will hold at your plants for raw materials, for finished goods at your warehouses, and then how do you sell it to your retailers, right. Transportation cost considerations is part of this model. Okay. In summary, the model enables a paradigm shift from reactivity to value based decisions, because you will be able to analyze all these scenarios upfront before you put this plan into action for your operations team to execute upon. Okay. As we previously covered, our model is a containerized independent model. In other words, you do not need SaaS to run this model. It could be new, but this is how this containerized independent models work. All the dependencies needed to run this optimization model are already within that container. So, it is kind of a self-contained software model or a product which you can take and integrate into your existing pipeline or existing framework. If you have a Python framework, if you want to integrate this optimization model or integrate this supply chain optimization model into that pipeline, you can easily do it. Right now, it could be a heuristic method of how you calculate your plans or how you optimize your plans. Now, this gives you higher flexibility and optimal decisions on your plans, right. So, you will be able to take this model, call this using an API and integrate directly into your pipeline, right. You can stay within your environment and integrate this into your pipeline is a key takeaway from this standalone model, right. I am going to show a live demo with two clients, Python and SAS, just for you to kind of get how this API is called and how we solve a problem. Okay, first, let us ensure that the container is running or this independent model is running before we access this API, which we are going to discuss. And again, what you see here is a custom workflow to demonstrate this capability, right. You can write your custom workflow, own custom workflow. If you already have a workflow, if you just want to integrate this API into your custom workflow, it is easy to do so. But I am going to show here some steps so that you will know how we can integrate that into your custom workflow, right. So, to start with, let's start with analyzing this or calling this API from a Python Jupyter notebook. Let me get here. Okay. So, this first block, we open the Jupyter notebook, and this first block is needed to import all the dependencies needed for running this workflow, right. These two in the second block, base URL and API key, are the global variables needed to access this API. Let me run this. Here is where the API magic happens. We define what is our API endpoint, and in this section where it says response, when we execute this, this runs the optimization model API, right. Let me run this. Once you start running this, did I click? Give me a minute. Yes, once you start running this, the API is called and it runs the optimization model. This is a prediction ID created for each independent run. This prediction ID will be used to store all your output files for this particular scenario, for this particular case, right, for this particular input data. Now the optimization has completed. This says the status of this prediction ID is success and we are collecting the prediction output now. Right. This is for a sample data. I am going to show you a VA report with all these summary results, but here in these two blocks we are going to summarize the data and put the output files in a local disk where we will be able to access, right. So, these are the set of output files which comes out of the model itself. Here I wanted to bring a point saying that these output files are both accessible in SAS dataset format and a JSON format. Why JSON format? If you are not a SAS native customer, you will be able to consume this JSON format, convert it into any database format you want and use it for visualization downstream, right. Here you can, I am going to show a quick plot within Jupyter Notebook itself, where I am going to plot sales by each customer, right. These are customers and this is sum of sales for this customer. This could be across multiple products. In this scenario, it is for multiple products. These are mock data and these are the sum of sales for these customers. Now, let us move to SAS. Again, a custom workflow written to show some insights on how you can use this model API within a SAS workflow, right. So, again we have some global parameters in this section of the code which is used in the workflow. These are these two global variables, API key and API URL, needed to access this model, and this is where we call the API and execute the model. As you can see, proc HTTP is a SAS procedure which is used to access and run any API. So, I am going to run this. And once you run this, the rest of the code is again custom steps to compile the output, aggregate the output and use it for further visualization. So, the visualizations I am going to show is from SAS Visual Analytics. We take this, load it into CAS data tables, load it as CAS data tables, the outputs, and then we are going to visualize it in SAS VA. Okay. So, the results from this run, as you can see, this is the overall KPI dashboard which shows the total cost, total profit and profit margin for this particular scenario, right. The total revenue is 147 million, the total profit is 14 million. The bottom chart here shows the split of these costs by these categories: purchasing, production, shipment and other. There are other tabs in this VA to give you more idea about your results from this scenario, right. Okay, so, this is a geo map of suppliers. The size of the bubbles here shows the spending for each of these suppliers. So, if you click on one of these suppliers, you will know which supplier, how many materials or what are the materials you purchase from the supplier. Let us click here, right. We can see the suppliers, how much you purchase from them, what materials you purchase from them, what is the cost you spend on these suppliers, all these details which the sourcing team wants to analyze, right. Okay. And then you have a detailed production schedule saying this is the plant, these are the number of lines, this is the number of products produced in this plant. So, let us click one of the plants, plant 4, and you will be able to filter all your details let me choose plant 4, and you will be able to filter what are the lines in these plant. I'm sorry. Okay. So, this plant has so many lines, and this is the utilization percentage of these lines. How many products you produce in this lines, how many times you or what is the amount of utilization this line has, right? And this can be used by the operations team or manufacturing team to deep dive into, will I be able to satisfy this production plan even before you put it into operations, right? So, this is a strategic level model, and you have other tabs like DZs, what is my flow between my plants and DZs, customers, how much I sell to these customers, what is the fill rate, etc., and what is my transportation plan in the network, right? Again, you will be able to filter, deep dive, and analyze a scenario before you put it into production. Okay, now what if analysis, right? Scenario analysis. Let's go back and run another scenario. I am going to set one parameter in my custom workflow indicating that this is a scenario run, right. I am going to change the data in the backend to show that this is a different scenario. And I am going to come here, run this workflow, right. Now, I am running a different scenario. Now, this scenario has no plant 6 because we are going to close plant 6. Plant 6 is one of our top producing plants in the initial base scenario. Plant 6 is undergoing some construction or some update or some you are going to add some lines or labor strike is happening, whatever type of disruption, right. We are going to close plant 6 and we are going to analyze what it or how it impacts your profit or revenue, right. Let us go to our overall KPIs. Now, you see there are two scenarios, right. The scenario 2 does not have plant 6. Your total profit reduces from 14 million to 11 million, right. This is where the power of this API comes in, where you can do all these what if analysis scenarios on the fly. Okay, let us go back to our presentation. And wrap things up, right. So, our model offers what if analysis capabilities. It is a data driven approach. It is a flexible framework to model and analyze any structure of your supply chain. It employs powerful and intuitive optimization at the back end to solve your complex supply chain problems swiftly, leading to the path to a resilient supply chain and unmatched customer value. So, with this I close my presentation, open for any questions. Yes. So, the model is a SaaS model. The optimization model is built within SaaS, but you do not need SaaS to run this model. So, the container will come with all the dependencies which is needed to run this optimization model.
For the clients who need to provide the information about, what is the unit cost to use this facility or which product line, etc. Are those input by the customers, or they have to work with a consultant from SaaS to implement all this?
Yeah, so both can be done, but if the customers have those provided inputs, or we have input data model and an output data model, the customers should they have to have the data formatted based on these input models. But if we need to step in and help, we can also do that. The consultants can also do that. Yeah.
What modules that in the SaaS that you're using for the optimization?
Oh, the main module is Proc Opt model. Proc optimization or Proc Opt model, that is the optimization engine itself. Other than that, there is a lot of data steps we use to kind of validate the data and So this offering has a detailed data validation even before the optimization begins, right? We validate your data, make sure your data is right for the optimization, and then we run the optimization model. You get to see all the details. Yeah. Not the backend details. So all the backend details are like proprietary. So not all the backend details, but you will have instructions on how to access and run the model for sure. Thank you.